In this video, I'm going to teach you how to reduce a matrix to its canonical form. So right here, we'll have a 3 by 3 matrix, and what it means to reduce this matrix to its canonical form is to make this matrix to look exactly like this. This is the identity matrix of any 3 by 3 matrix. So trying to reduce this to look like this, we'll follow some steps, and we can do this either through the row reduction, or we can do this using the column reduction. But in this video, I'm going to use the row reduction to reduce this matrix to its canonical form. And trying to reduce this, the basic things that we look at here is we'll look at each column. Right here in this column, we have 1, and then every other number under it is 0, and here in this column we have 1 here, and every other number, the first number on top of it and this one below is 0, and then we'll have 1 as the last number in this column. And how we reduce this is, first of all, we look at the first number that we'll have in our matrix, and then reduce it to 1, and then use that number to reduce every other number under it to 0. And that's what we'll be doing in the next one. We look at here, we reduce this to 1, and then reduce every other number in that column to 0. So trying to reduce this to 1, there are two ways that we can do this. Right here we'll have 1 here. We can decide to bring this one to change the two rows, bring the first row to be bring the second row and make it to be the first row, and then bring this first row and make it to be the second row. Doing that, we'll have 1 here, or we can decide to divide everything that we'll have here, and then doing that to make us to have 1 here. So I'm just going to write out the two iteration. I'm going to divide this by 1. So dividing this by what we write here is we write row 1 times the multiplicative inverse of 2, which is half. And so multiplying that first row with the multiplicative inverse, we'll have something like this. In the first row, we'll have 1 here, and then 3 times half will give us 3 over 2, and then minus 4 times half will give us minus 2. And so we'll write out the other rows the way they are, and then we'll have 3 minus 1 and 4. But if we decided to change the two rows, we'll be having something like this. We'll have row 1, comma 2. That will be changing row 1, making the row 1 to be the second row, and then bringing the second row to be the first row. And then we'll have something like this. We'll have 1, 2, and 3. That is bringing this up, and then bringing this down. We'll have 2. We have 2, 3, minus 4, 3, minus 1, and 4. And so doing this, we have been able to make the first number in our first row to become 1. And that's just the sentence, almost sentence that I'll have here, just that the metrics are not the same. In this case, we changed the first row and the second row, but in this case, we decided to multiply this with the multiplicative inverse. Whichever way you choose to go through this, you can. Whichever step you choose to use will still arrive at the same answer. So I'm going to just wipe this off and then continue with this. You can decide to continue with this using this to reduce every other number under it, but I'm going to use this, and I'll use it to reduce this to 0 and reduce this one also to 0. After getting this, the next thing that we'll do is we try to use the first number here, which is 1, to reduce every other thing under it to become 0. And how do we do that? We are going to use the first row. So we are going to have something like this. We have arrow 1, comma, we want to use the first row to reduce the second row. So we have arrow 1, comma 2. And what are we going, the number that we are going to be using to reduce it? Right here we'll have 1. So the number we are going to be using to reduce it is the additive inverse of 1. So additive inverse of 1 here will be minus 1. And so we'll have minus 1. So what we do here basically is we have minus 1 here, what we are going to be doing is you use minus 1 to multiply every number in the first row and then add it to the numbers that are in the second row, and that will give us the new second row. So what we are what this thing means is uh, minus 1 times all the numbers that are in the first row plus the numbers that are in the second row, and that will give us our new second row. And so we'll be doing that, and that will give us the first row will not be changed, so it will still remain the same. Right, I'll have 1, I'll have 3 over 2, and then we'll have minus 2. And then using this to reduce the second row, we'll have 1 minus 1 times 1 will give us minus 1. Then if you add 1 to minus 1, we will have 0. So we'll have 0 here. And then minus 1 times 3 over 2, that will give us minus 3 over 2. And then we add it to 2. So we'll have 3 over 2 plus 2. And that will give us 2 times this is 4 plus this, and that will give us 1 over 2, I think. Yes. So I'll have 1 over 2 here. And then we go to the next number here, we'll have minus 2. And then multiplying it with minus 1, we have 2. And then adding it to this, we have 5. And so the third row, how are we going to reduce the third row? Here we are trying to make this place to be 0. And so we'll be using the first row, which is already 1, to reduce it. So what we'll be having here is something like this. We'll have R1, 3, that is the first row, the second row, then multiplying it by the additive inverse of 3, which is minus 3. So what we are having here is minus 3 times row 1 plus our third row, and that will give us the new third row. So multiplying this with minus 3 will give us minus 3, and adding it to this will give us 0. So we'll have 0 here. Then minus 3 times this will give us minus 9 over 2. And then we add it to minus 1 here. And so we'll have minus 9 over 2 minus 1. And that will give us minus 11 over 2. And so right here we'll have minus 11 over 2. And then multiplying this by this, we'll have minus 3 times minus 2, that will give us 6. Then plus 4 will give us 10. And so we have our new matrix. So we are progressing. Right here we have succeeded in making this place to look exactly the same with the first column. And so the next step that we do is we look at the second column. In the second column, this is where we have 1. And so we try to make this to be 1 and then use it to reduce every other numbers in that column to become 0. So right here we'll have 1 over 2 instead of 1. So how do we make this to become 1? We multiply it by the multiplicative inverse, which is 2. So multiplying this with 2 will give us 1. And so we have R2 by reducing the second row, and then we'll have R2 times 2. So multiplying everything in second row by 2, the first row will still remain the same. Or let me just write out the second row. So multiplying the second row by 2, we have 0. And then multiplying this with 2, we have 1 here. And then multiply this with 2, we have 10. And after doing this, the next thing that we'll now do is we try to use this one to reduce every other thing in that column. So the first column, how do we reduce the first column? We multiply it by the additive inverse. So we're going to use the second row to reduce the first column, the first row. And right there we'll have 3 over 2. So the additive inverse of 3 over 2 is minus 3 over 2. And so we will multiply this by minus 3 over 2 and then add it to what we have here to get our new row. So multiplying this with minus 3 over 2 will give us 0, plus 1 will still give us 1. and then multiplying this with minus 3 over 2, we have minus 3 over 2, plus this, we have 0 there, and then we multiply this with minus 3 over 2, and 10 times minus 3 over 2, that will give us 15, minus 15. And so adding it to minus 2 will give us minus 17. So we have minus 17 here. And then we look at the third row. We use the second row to reduce the third row. And how do we reduce it? Right here we have 11 over 2. So the additive inverse of minus 11 over 2 is 11 over 2. And that's what we'll be multiplying with. So multiply the first number here with 11 over 2 and add it to this. I'll have 0 here. Multiply this with 11 over 2, we have 11 over 2. I'll add it to this, we have 0. So multiply this with 11 over 2, and we have we have 5 times 11, that will be 55, and then we'll add it to 10 here, and so we'll have 65, and that will be it for the second column. So we have succeeded in reducing the first column and the second column, remaining the third column. And right here in the third column, the place that we are supposed to have 1 is in the last number in the third column. And how do we reduce this to become 1? We will reduce this to become 1 by dividing it with 65. So the third row, we'll be multiplying the third row with 1 over 65. So right in the third row, we are just going to make some adjustment to the third row. So multiplying this with 1 over 65 will still give us 0, and we'll still have 0 here. Then multiplying this with 1 over 65 will give us 1. And then going to the first, we're going to use the third row to reduce the first row, which is trying to make this to be 0. So right here we'll have 1 already, and then we will use the third row to reduce the first row, and we'll be doing this with 17, the additive inverse of what we have here. And so we have the additive inverse of minus 17 is 17. So we are going to multiply this by 17 and adding it to what we have in our first row. So if we multiply this with 17, we have 0, 0 plus 1 will have 1, and then multiply this with 17, we have 0, 0 plus 0, we have 0 here, and then multiplying this with 17, we have 17. So 17 minus 17 will give us 0 here, and then we use the third row to reduce the second row also, because we have 10 here. So we have arrow 3, 2 times the additive inverse of 10, which is minus 10. So multiply this with minus 10 and we have 0, and add it to here, we have 0 here. Multiply this with minus 10, we have 0 plus 1, and we have 1. And then multiply this with minus 10, and we have minus 10. I'll add it to this, and we have 0. So right here we have succeeded in changing this matrix here to its canonical form, reducing it to its canonical form. And these are the steps that we took. First we multiplied the first row with half, and then we took this step and this step and this. So that got us to this. So reducing a matrix to its canonical form, we can use it to solve various type of questions. We can use it to solve for a system of equations. We can also use it to get the inverse of any matrix. Thank you for watching the video.